Hello everyone and welcome to my new video. In this video I'm going to talk about factorization. I decided that I'm going to start a new series of videos in which I explain certain maths topics. I'm going to start with this video, which is factorization, and go onwards till the end of the A-level content. Today we're going to look at complete factorization, partial factorization, and factorization of binomials. Regarding that, I'm going to focus on the difference of two squares, the difference of two cubes, and the add up of two cubes, and how we can use certain shortcuts to factorize correctly these types of binomials. Let's say we have this following polynomial: 3a cubed b to the power 4 minus 6a squared b cubed plus 9ab to the power 5c. First thing you need to do is to identify the maximum common divisor. What do I mean by that? The maximum common divisor is that thing that every term, and by that I mean each of these three, would be able to be divided by it. And so each one of these is a multiple of that maximum common divisor. In this case, our maximum common divisor would be 3ab cubed. And we multiply that by the quotient, so we would divide the whole thing by this 3ab cubed. And if we divide the whole thing by 3ab cubed, we would get a cubed b minus 2a plus 3b squared c. So this is a maximum common divisor, and this is our quotient. Okay, so that is how the complete factorization works. And we say it's complete because you end up with a product. Let's get on with the partial factorization then. Suppose we have 5ax plus ay squared minus y squared minus 5x. The first thing you need to do before going on with the partial factorization is checking whether there is a common divisor for all the terms. In this case, there is not, and that's because there is no term that is present in all of them. So what we do is that we split the polynomial in two parts or more, depending on the polynomial you're faced with. For this polynomial, split it in two. So you can reorder the terms if it's easier for you. So you can rewrite it this way, so that you put the terms that have some common divisor near each other. Okay, so we order it this way. So now consider this bit here and this bit here. What's the common divisor for the first part? It's 5x. And the quotient would be a minus 1. So we divide the whole thing by 5x. Similarly, we transcribe the same sign. You can change the sign, so you can put it as a minus for the sake of your factorization if putting a minus would give you the same thing in the bracket, but in this case a plus is fine. So we transcribe the plus, and then our common divisor is y squared. Okay, if we try to find a quotient, you would get a minus 1. Look at that, we have the same term in both parts. So we have the a minus 1 is our common divisor. Disclaimer: the common divisor can be a binomial, can be even a polynomial. It doesn't have to be a monomial like in this case. So do not feel scared if you're faced with a binomial as a common divisor. So let's get on with this then. Our common divisor in this case is a minus 1, and our quotient, what we would do is that, suppose you have to divide 5x times a minus 1 by a minus 1, you would get 5x. And similarly, if you do that with the other term, you would get y squared. So this is our final factorization. A particular thing in this partial factorization is that I always consider partial factorization as being somehow a step to reach complete. Because in here, we did complete factorization, isn't it? Because there was a term that was present, a term that was common for the whole polynomial. But in here, we did partial. So that's why I refer to partial as being sometimes a step to reach complete factorization. It's called partial because, it's a step, and also because you end up with a sum. So it's not a product, as we saw with our complete factorization.